Hello, good night. How are we?
Night, sir.
Well gone.
Good night.
Nothing much, sir.
On a song.
A shitty day.
Sir.
What kind of day was that?
A bad day, sir. A bad day.
Okay, I think I heard that word, bad day.
Yes, that's
Sir,
what.
we don't know about Krishna, but my day was great.
Ah, great. I'm happy for that. Nice. I don't even know how my day was. It came and just went. And truth, I went lying down to say that I have 2 hours for class. Let me go get a nap. And then the Spirit of the Lord said to me, don't nap, because it's going to be tomorrow morning situation. So I was just up browsing the internet, waiting for you guys to come on. So it's not a bad day. It could have been worse. I've had worse days. So I'm just happy. Kind of concerned with that. Normally at this time on a Thursday, when because it's a late class, people would have joined on time. I'm only seeing 11, 10. Kind of concerned that people are getting a little bit lax, or maybe they're tired. I don't know. But I need to see you guys coming out for class and coming out early. All right. So this is it. This is it.
We made it, sir.
Yeah, man. You good, man. Made what? There's something? What are you talking about?
Sir, you said this is it.
Oh, yeah, man. This is it. We're kind of wrapping up. We have just 1 week of school left for this semester. Well, for this leg of the semester. And I'm looking forward to wrapping up the integration today to start tonight the applications of integration. I mean, differentiation and integration. And to just run it. It's been a good semester so far. So let us see what will happen. Somebody has just joined. Who was that? Okay. Shana, you were absent from my class last night. Shana, you were absent from my class last Tuesday. And I came and I asked and I didn't hear or see a message from you guys. What's happening? Shana Lee? Miss Wind? Miss Smith? Shani and Shana, can you unmute for me, please?
Sorry, talking to me?
Why would I talk to you? You don't want to answer me.
Oh, sir, I just come out and nice.
Oh, okay.
Good
One
night.
Tuesday, I'm not see you at all.
Tuesday. Oh, sir, class early. When we
Class
reached
done
home, it
after
was less than
schedule.
30 minutes. So we just never log in.
Oh, come in, same way, man. Get I come catch the last part of the something. I'm done that one day already, so you miss it. Come in now, go over that, something new made tonight.
Sir, that's fine.
Yeah, man, come here, do some mental maths on top of that, too. All right, so see if you can catch on. If you don't catch on, message me, yeah?
I will.
All right, cool. Shana Lee, on you, please. Why do I have to
Good night.
You don't want a good night from me. Why do I have to
take it back?
Well, take it back. Why do I have to beg you to talk to me?
When you beg me to talk to you?
Every night. You know, can I beg you?
Oh, so much people I talk to you, me not really need to talk to you.
No, no, that's not the spirit. Me want to hear your voice. Talk to me. Talk to me. Chat to me, man. I want to hear you. All right, guys. The
You kind of sound muffled. I don't know if it's me.
I saw muffled. Well, guess what? I'm using my speaker, and I'm not lounging tonight, so I'm in good environment. So I don't know. Check yours. Am I sounding muffled to anybody else?
No.
Okay.
Not really, sir.
Okay. Hey, Sash, you know, they want me now. Hey, hey. Sash, away there.
Yes, sir.
Away there, you know, there you are. Away there.
Yes, sir. I'm home.
All right. Never mind here. Don't follow me. I mean, Germany's impression is rubbing off, man. It's not a good thing at all. I mean, I shouldn't be like German at all. All right.
True, sir. True.
Yeah, man, I know that, man. I don't know why I'm allowing him to influence me. Alrighty. So we are on to our integration by substitution. All right, let me just confess something to you here. When I read the syllabus, it wasn't so explicitly stated, and I feel it into my spirit that these guys are going to come to set us up. So I say, you know what? Let me spend a few minutes and I'll show you how to integrate using the substitution method because, boy, yeah. So it wasn't explicitly stated, and but based on how them write it, I say, you know what? Let me go through with it because I don't want any surprises the day of the exam. The day of the exam, while you are doing the exam, I'm supposed to be driving down to Ochi, having a nice meal, and not having to worry. Sir, the exam was hard. Nope, that's not true. All right, let's get to it. Share screen. So as I said before, we're looking at some integration by substitution. It is not difficult. It only looks difficult without solving the question without substitution makes it difficult. But I honestly hope that I'll be able to do a good job in presenting this topic to you. Where's Vito and Unique and Ryan and who else is missing? And that Jesus, what name again? Kamish. Let's see if I can go through the list again. Bam, 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 bam. We'll call 4 and 13, 17, 18, 19, 20, 21. 4 more. Which 4? I'll be honest here. All right, Judy. All right, Lifton is here. Yeah. All right, let's go. So here we go. Hope you guys are ready. Mhm. Um, let me do something here. This one kind of lookish, bigish. Yeah, I don't think I should start with. You see, oh, easy something, you know. I have only 3 examples here for you, but I don't like example number 1. I don't think I should start with example number 1 first. Let me put that as example number 3. put I'm going to paste 3 examples of these, and then we're moving on.
So remember the cake for Christmas here?
You know, at first, you know, when they say if it reached, I thought that's what you're talking about. That's what I was saying. What are you talking about? Bye bye. So that's 1, 2, 3. Oh, Jesus. Cake for Christmas. I should put in my order. Charlene, you can be it? For other people, that is. I know you bake for somebody else, but you're baking for other people, Charlene.
Repeat, sir.
You're baking cake for other people. I know others would have put in your
I'm
order.
baking cake, sir.
Yeah.
No, sir.
Okay.
No cake, sir. I had all my cake on Monday, sir.
Selfish. So you're gonna share some?
Sir, I shared it, yes, sir, with some
Oh,
persons.
sorry. Okay, all right. Don't go no further because I'm not going to ask you who, because I think we all know.
So I told them share the cake. Me not talk.
Not talk. It's life though. Anyhow, all you have to do is just open a pack of chicken noodle in a 1 little cup with some hot water, and we can burp 2 gas. We want to come witness it here. Let's move on. So I've changed the question. Not that the question wasn't solvable, but it was a big-ish question. The answer was very huge. So I don't want to start off with that one. So I'm starting with this one here that says, by using the substitution u equals 2x minus 1, you're asking us to integrate x times 2x minus 1 to the 4th power between the limits of 1 and 0. Between the limits 1 and 0. So let me tell you how else you could do this question. And if it wasn't to the 4th power, I'll show you how to do it that way. Let me show you how else we could do this question, maybe. Yeah. This question here would have to go and say 2x minus 1 and expand that to the 4th power and then multiply it out by x, and then we're going to get a polynomial, and then we integrate, and then we do that. That's way too much work. That's way too much work. And guess what? When we're expanding 2x minus 1 to the 4th, because it's so much work, chances are we make a computational error. And in making a computational error, it is going to throw up the answer. So there's a nice way of doing this integration, a very nice way of doing this integration. And the way we're going to do the integration is by a substitution. By substitution. Now, I'm looking for they gave me the substitution and asked me to use u to be 2x minus 1. So I want to work with the process because guess what? This is supposed to be, as I said before, I have only 3 examples and then I'm moving into something else tonight. This is not difficult because most of the question you already know how to do. It's just a start of the question that I need to go through with you. But most of the question, you already have this. All right, let's go. So it says, I'm going to let u be equals to 2x minus 1. Now, the mere fact that they give me this, it means that I'm going to differentiate. Now, one trick is, let me not tell you the trick yet. It's too early in the game. So I am going to be differentiating my substituted function. So I'm going to find du by dx. Remember, it can't be dy by dx because the function is not in y, it's in u. So I'm going to say du by dx. I'm differentiating du by dx, and I'm going to get 2. Because the differential of -1 is a constant, which is equal to 0. So when I differentiate 2x minus 1, I'm going to end up with 2. And what I did was also put that 2 over 1 because I want to make a substitution for dx. Remember, the question is by substitution. So I'm trying to find a substitution for dx because I am making a substitution in u. The question is in x. It means that everything inside here so must be u. This is supposed to be u, and this one is in x. So is this 0 in x. So I have to go and make the substitution to get them in u. So everything about this question is in x. Let me read it. It says the integral of x times x squared, 2x minus 1 to the 4th power, dx. So it means then that all of this is in x, and the upper limit is also in x, and the lower limit is in 0. So when we're doing our integration by substitution, what it means is that the upper limit and lower limit has to be reconverted to u, and everything inside here, the function, must be changed to u, and this dx will have to be changed to du. So what I'll now have is an integral in u. All right. So this is what is going to happen. So du by dx, when I differentiate it, I'm going to get 2. I'm putting this 2 over 1, and when I cross multiply, I'm going to get du is equals to 2 dx. See here? Du is going to be equals to 2 dx. So I don't say that, no problem. I'm putting this 2 over 1, and I'm cross multiplying. So when I cross multiply, this is how I do the cross multiplication, just like a cross, right? So du times 1 is du is equal to 2 times dx is 2 dx. So this is what I get. But I want a substitution for dx. So I want dx to stand alone. So I'm going to divide both sides by 2 in order for me to get dx standing alone. And du now will be over 2, right? So I'm making dx the subject of the formula. So this is one piece. This is the first piece. The first piece is to differentiate the substituted function. The first piece is to differentiate the substituted function. Now look at the next piece I'm working on. Is to convert the upper limit from x to u. So remember now, u is equals to 2x minus 1. So let us look at the upper limit. The upper limit is 1, but this is the value of x. So x here for the upper limit is 1. So anywhere in u I see x, I put 1. So this becomes 2 times 1 minus 1, which is 2 minus 1, which is 1. So the upper limit for u will remain 1, but this is no longer in the upper limit for x. For here, the upper limit for the question, sorry, will remain 1. But this is no longer going to be x equal 1, but it's going to be now u equals 1. All right. Similarly, I'm going to be working the lower limit. Now, remember, everything for the function now will have to be in u. So I'm looking at the function. Anywhere in u I see x, I put 0. So it's 2 times 0 minus 1 is 0 minus 1. So my new lower limit is going to be -1. So I have changed 2 things. I have changed my upper limit. I have changed my lower limit. Also, I went ahead and differentiated in order to change what is happening here. So 3 things are changed so far. 1, 2, 3. And I have them here. 1, 2, 3. Now I'm going to do the substitution. No, I'm going to do the substitution. Come on. No, I'm going to do the substitution. Remember, this is a question. And u is equal to 2x minus 1. So what I'm going to do now, I'm putting all of this now to be u. So I'm going to have x, u to the 4th du. Sorry. You notice what I've done here? I have made a substitution for my u up here, my new upper limit, and my new lower limit. I have made a substitution for my dx to be du over 2, which is right here. And I've now made a substitution for u to be equal to 2x minus 1. So there are 4 things that I have done. The upper, the lower limit. I'm making the substitution for what it is that they gave me. Plus I'm making my substitution for my dx. What is important, guys? Do you recognize that I still have an x in the question?
Yes, sir.
Right. So I can't leave it like that, because if the question is now saying that I need to differentiate, I need to integrate with respect to u. So everything in here must be u. So look at what I'm going to do. I'm going to go back to what my substitution is. U equals 2x minus 1. and I'm going to transpose for x so that I can substitute it for u. So u is equal to 2x minus 1. U is equal to 2x minus 1, see here. So when I add 1 to both sides, I'm going to get u plus 1 is equal to 2x. I divide both sides by 2, and I'm going to get u plus 1 over 2. U plus 1 over 2, and that's the value of x. That will be the value of x. So now I'm making the substitution for x. Now I'm making the substitution for x. See what x is? See what the integral was so far? The integral here, x u to the 4th times du over 2. Now if you look at it here, I am now making a substitution for my x. So my x now becomes u plus 1 over 2. And this is what I'm putting here as my x. My u to the 4th is here, and my du over 2 is here. So everything here now in the function must be represented by u. So look at what is happening. I'm putting them together. This 2 times this 2 gives me this 4. And this u to the 4th, u plus 1 times u to the 4th, that's it. Yes, Miss T, more letters. And then what I'm going to be doing now, just taking out this 1/4 because it is a fraction, and we know that what we can do with a fraction form, a fractional form. We know what we can do with a fractional form. So what we're going to be doing here is to say u plus 1 times u to the 4th. But u plus 1 times u to the 4th, I can do this multiplication pretty easily. U to the 4th times u is u to the 5th. What I've done here, though, was to take out this 1/4. This 1/4 is taken out and put outside of the integration sign. And you know this from rule 6. So u to the 4th times u is u to the 5th, and u to the 4th times 1 is u to the 4th. So this piece now becomes very easy to integrate. Extremely easy to integrate. All right? Very, very easy to integrate. And then when I integrate here, oh, so this is where you know. So you know up to this part. But let me just run through this quickly so I can go back up top. So this part, you're adding 1 to the power divided by the new power. See here? U to the 6 over 6. You're adding 1 to the power divided by the new power. U to the 5th over 5. And of course, you're going to have your square brackets where you have your upper limit, your lower limit, and this 1/4 must itch up side of it all the time because it now becomes a multiple. Anywhere in the integrated function, I see u, I'm going to put 1 right here, so. Minus, anywhere again in the same integrated function, I see u, I put -1 right here, so. Just making a substitution. This I know you know how to do. Then I'm going to be evaluating here. 1 to the 6 is simply 1. 1 to the 5th is simply 1. -1 to the 6, oops, when I'm raising a negative number to an even power, it becomes positive. That's why I have a positive 1 here. However, when I raise a negative number to an odd power, the number is negative. So that's why I have a -1. So I change this positive sign to a negative sign right here. And then what I'm going to be doing now is just removing the parentheses. So this becomes 1/6 right here. So that is 1/5 right here. This -1 multiplied by this 1/6 to give me -1/6. But watch this magic. This negative sign multiplied by this negative sign gives me this positive sign. And then what I have is going to be positive 1/5. Positive 1/5, positive 1/6 minus 1/6 cancels out. So all I have is going to be 1/5 over 1/5, 1/5 rather plus 1/5. The denominators are the same, so I just add my numerators. 1 plus 1 is 2, so I get 2/5. You notice that all of these are being multiplied by 1/4. It will not change. And then I'm going to say 1 times 2 is 2, and 4 times 5 is going to be 20, and 2 over 20 is equal to 1/10 unit squared. So this question here is, when I evaluate it, I'm going to get 1/10 unit squared. All right, so let's go again. So looking at the question, there are several things that must be done before we can do anything else. When you're given a question like this, the question is, if the question says integrate x times 2x minus 1 to the 4th power with respect to x, you know, when they say the dx, that's what it means. You're integrating with respect to x. But the substituted value says u is equal to 2x minus 1. What it means is that you will have to go ahead and change out everything, the upper limit, the lower limit, the function itself, as well as what it is that you're integrating with respect to. So there are 5 things that you're changing. 4. You're changing the upper limit, the lower limit, the function. 3, and what you're integrating with respect to. So there are 4 things that you're changing. All right. So what it is that we're doing is to change the, in order for me to change that, I'm going to have to differentiate. In order for me to change the dx, I'm going to differentiate. So when I differentiate, I'm going to let u to be equals to the 2x minus 1, which is our differentiated value, And then I'm going to get 2x. I'm going to get 2 rather, because I'm differentiating 2x, I'm going to get 2. I'm going to be dividing this 2 by 1 so that I can cross multiply. Du times 1 is du, see it right here, so. And 2 times dx is 2dx, see it right here, so. Remember, I'm trying to find a substitution for dx, so I want dx alone to be on one side. So everything else I'm going to put on the other side. So how do you do that? Recognizing that the 2 is being multiplied by the dx. So in order to get rid of it, I have to undo that multiplication. And I can only undo something that is being multiplied by doing division, because the opposite of multiplication is division. So then I divide both sides by 2, I'm going to end up with du over 2 equals dx. So that's the first piece of substitution that I have. The next piece is just to look at what the substituted value is, what they give me as a substituted value. And then all I'm going to do is to substitute the value, the upper limit, into it, and to work out the corresponding lower limit and the upper limit. So you notice that the function
Can I ask a question, sir?
correct.
All right, so you said you differentiate that part. That's the first part, right? So the du over 2, where, oh, never mind.
Okay, thanks for seeing it. So I think that was copying that because I want to paste it here and there so that you can see what is happening. So those are the functions. So those are the functions, or the function that I'm using for my upper limit. And anywhere in the upper limit I see x, I'm going to put my 1, because that's what the upper limit in x is. I mean, at 2 times 1 is 2 minus 1 is 1. So this is now my upper limit in u. That's my upper limit in u. And similarly, the lower limit in x is 0. So when I multiply 2 by 0, I'm getting 0 minus 1 is going to be negative 1. So my lower limit in u is negative 1. So what I'm doing now is substituting all that I have so far. And when I see what I have so far, I've substituted my upper limit, also did for my lower limit, also did for dx, and I also did for the function. And when I've done that, I recognize that there's something left. Then, sir, why never just wait until you have everything and then you substitute? The truth of the matter is, there are times when some things will cancel out. This one here, it just never cancel out. So we have to go again now to do one more substitution. And that other substitution now is to go back to my u equals 2x minus 1, and to make x the subject of the formula, because I need to get rid of this x. This question in itself is not solvable because I cannot integrate with respect to u, and I have u and x in here. Okay. So I'm transposing. So I'm going to say u plus 1 is going to be equal to 2x. I want the value of x. So anything that is beside the x, I'm going to do the opposite in order to get rid of it. Now that 2 is being multiplied by the x. So I'm going to divide both sides by 2. I'm going to have u plus 1 over 2. And there's 2x over 2, which will give me just x. Now, here gives me my total full sum substituted value. You know what? Let me represent that in a special color. Right? So this total substitution took place right here. Then I'm fixing up now. I have a 2 in the denominator on this side, and I have a 2 in the denominator here. So when I multiply the two of them, I'm going to have 4 right here. So then I'm going to have my du here. So then I have my u to the 4th. And then I recognize that the 4 in the denominator here, if I factor out 1/4, it means that I get rid of this 4. So that's why I went ahead and factored out the 1/4 right there. That's the only reason I went ahead and factored out the 1/4. Factored out the 1/4, and I get rid of it right here. Yeah,
Sir,
don't get rid of it, but I mean, I put it one side. Yes, please.
all right, so you said that you factor out the 1/4. You have u plus 1 over 4, right?
Mm-hmm.
Which is it that you take the quarter out of that?
Mm-hmm.
Because I see in bracket you have u plus 1 again.
Mm-hmm. So remember, you know,
So where the other 1 come from in the bracket?
right. I am coming. Cut. Paste. Bam. Then I have to cut again. Paste. Bam. Paste. Enter. And then now I'm going to copy. Bam. Paste it over here. So, and this is what I'm going to show you, Shash. No, that's not what I need to show you. That makes any sense to you? No, that's not what I meant to do. So this Shash, u plus 1 over 4 is the same thing as 1 times u over 1 over 4. So there are two things that I can do. I can either take out a quarter. Yeah, that's really one thing. I can take out this 1/4 and it times u, because 1/4 times u copy, because that is equals to that 1/4. All of that piece here divided by the 4 is the same thing as having just 1/4, which is equals to u plus 1, this same u plus 1. Because when I multiply u plus 1 by 1/4, I'm going to get u plus 1 over 4. See it right here, so? See it right here, so? And then now the u to the 4th du is just the same u to the 4th du. So this has not changed. The only thing that looks like it changes is this one here.
Sir,
See,
I would never imagine that a 1 would be up top there.
yes, man. Trust me. You see that magical something? Yeah, man. Trust me.
So that's how it always will be.
Every single time.
Okay.
Before, no, and always. Yeah, man. But I'm happy you see it now. And then, now that I recognize everything is in you, I'm factoring out my 1/4 because I recognize that, you know what? I can go about doing my stuff otherwise without having to integrate this 1/4 and just factor it out. It's a constant, so we can take it out. Rule number 6. Then we're going to have u plus 1 times u to the 4 to integrate. You say, you know what? No, product rule, not something here. I'm going to multiply out that and then just get one polynomial and we can just integrate easy. Add 1 to the power divided by the new power. We know that at that lock. So you're going to say u to the 4th times u is u to the 5th. And then u to the 4th times 1 is going to be u to the 4th. Now this is a much easier form to integrate than this form up top here. So remember the rule. Add 1 to the power. Divide by the new power. Add 1 to the power. Divide by the new power. I'm adding 1 to 5. I'm going to get 6. And I divide by 6. I'm adding 1 to 4, I get 5. And I'm dividing by 5. Now I have my upper limit and my lower limit. My upper limit and my lower limit. And as I said before, I know you know it from here. Just remember though, that this 1/4, it chop every single time outside of the something. It chop. No move. All right? Anywhere in the integrated function, you notice I'm emphasizing integrated function because some students go into the exam and they will integrate the function, you know, all them going to do is substitute in the function and say, answer, sir, answer to what? You have to integrate the function first. So remember that we're integrating first. And when we integrate, we add 1 to the power divided by the new power. Now, having integrated the function, anywhere in the function you see x, you see u rather, you're going to substitute your upper limit, and then you're going to do the same for the lower limit, and then you subtract, and it goes there, and that's the end of that question. This part I'm going through like that because I know you know how to do this part already. The top part with the substitution is what is new to you, and that's what I'm spending some time on. Question, ask me your questions now, because as I said before, there are only 3 questions that I've generated for this area. It's really not difficult. So mostly I have to really work with the substitution. Go ahead, please.
So, sir, what all of that exam the upper top for?
All right, sorry. Speak up for me, please, son. Yanni?
Hearing me better now?
Yeah, man.
Sir, I'm asking what is the purpose of the top part?
What do you mean the top part? Top part of the question?
Mm-hmm.
Which part? Right here, so or this?
No, as in the whole, is just another complicated way of doing the question?
Yeah, man. So when you get a complicated question to integrate, they will say to you integrate it by parts. Yeah. Yeah, man. All right. So let me see if I can find you an example now. All right, put it this way. If you sometimes, I've seen this happen many times. You may have like a business place, like there's one business place in an area that I pass daily. They offer a restaurant, right? Well, I can't tell you, it's a Burger King. But it so happens that I knew somebody who was living beside, in a dwelling home beside this Burger King. And one day the friend says, if I know anywhere renting, I said, why? He said, because we got notice to move. I said, serious? Yes. Burger King bought the residence and they're going to use it for parking lot. And then I got upset to say, but they're out of order. People living in a good place and you go come in at a good place, come buy one plot and put it on Burger King. Mark, yeah, it add to the area, yeah, but they're gonna make some money out on a house because they're gonna make it for parking lot. So I said to myself that I'll never ever park over there because me have my one-man boycott. What's the point? When Burger King was doing their survey and they're trying to find the area for which they have, they never had this lot next door to them in their original stuff. What's the point, Annie? Sometimes you get some functions that it becomes complicated after a while. So in order for you to integrate it to get the area, the total area, is by making a substitution. So they will now have to go and substitute their title. Because if there were 1 to 3 Bougainvillea Avenue, the mere fact that they bought Number 5, there are no 1 to 5 bougainvillea. And the titles office is going to have that record to say it's 1 to 3 and 5 was added at this time. So we always have a record of what was happening. So it complicates matter somewhat because it's no longer 1 lot, it's now 2 lots. So, don't worry too greatly about it. We will be able to see ourselves through. What I'm going to do for you, if there are no other questions, what I'm going to do is I'm going to project that question. I'm projecting that question. And in projecting that question, I am going to ask you to do 3 things for me. I want you to differentiate this function in order to find dx, differentiate it and solve it in order to find dx. I also want you to replace the upper limit and the lower limit. And let us see what else is there to do. So I want you to do 3 things. Differentiate the function. Differentiate the function. You're going to resubstitute to get the upper and the lower limit. And when you differentiate the function, you're going to go ahead and work that for me. I'm going to give you 5 minutes to do that. Just take your time. Let me know. Can you just take off this question for me? All right. Let me do this.
That's what I'm doing, sir.
All right. That's coming to you, honey bunches. Let me do that. And let me do this. Oh, Lord Jesus. And let me just highlight this. So when I highlight it, it means that this is a new question for the day. Right? So it looks like this question. So this is what I want you to do for me. This piece up here. We're doing it in pieces. Stepping away for 2 seconds, and then by the time I come back, we should be finished.
Sir, so where the 2/1 they come from? Sir,
And step away, Yannick.
uh, anybody can explain where they get the 2/1 from?
Differentiate the 2x minus 1.
Okay, thank you.
Is Sarah back?
Oh no, must finish this by now.
So you know that me I call you?
Mm-mm. Me go end of the season, go get some water, and then go put it on for boil, for make like a tea. So hush. What go on do?
Sir, I wanted you to scroll down.
Oh no, I apologize. I know I have the tablet on, you know, so I could have walked with the tablet to the kitchen. Let's go, let's go, let's go. You want me to scroll down to where, hon? No, but I'm not my answer for the Sash. Hold on, the man, Sash.
Oh,
Come on, you drop the gun, Sash. Me ask if you do upper limit, lower limit, and a piece, yeah.
sir, we never heard about this.
Yeah, man.
No,
So,
finish
have
it.
you done that?
Yes, sir.
Nice. So, shoot. What did you get for the value of your upper limit?
4.
4, sir.
Everybody agree with 4?
Yes, sir.
Yes.
Nice. I love it. And what's
Yes,
the lower
sir.
limit?
-1.
Negative
Negative
1,
one.
sir.
Very nice. I love it. What is the substituted value or function for dx?
The du over 15 x squared.
I don't know if that one is correct.
Sir, that me get to.
I'm troubling you, man. Yeah, only name bright, you know. It has to be correct. All right, my question now. Is there anyone in the class that did not get this piece, or this piece?
Yes, sir, but I see what I did wrong.
Okay, and guess what? And that's the beauty about it. The beauty is when you see your errors, I can't complain. When you're not seeing it, I'm worried.
I did not get the top part. I didn't know what to do. I get
For the
the
last part.
du over the dx equal the 15x squared, but then I didn't know how to move on from there.
Oh, that's fine. But that's all I asked you to do, you know, hon. That's all I asked you to do. I didn't want you to do anything else for now. Well,
But
no.
no, sir, I want you to explain the
Must see
after
my
the arrow.
error as well. For the
So,
last one. Sorry.
Okay.
sorry.
Okay. No, I think you're Anika saying the same thing, Krishna. So, Nika, let me get you first. Ouch. Let me get you first, Nika. You're saying that you didn't get this piece right here, so?
Yes, sir. I didn't know how to move on after that one. What exactly did you do to come over there?
Okay, tell me what you have, Nika.
Sir, I have everything over there before over this side. Yes, I
you
have
have,
that.
you have all of this.
Yes, sir, but I didn't know how to
Gotcha.
move on.
Got you. Soon talk to you. Krishna, where's your problem?
The last part, sir. The -1. But
When you raise a
but
negative.
I figure out my error though. I did figure out my
Okay.
error. But this was
Okay.
that was where I got it wrong.
Yeah, but just to say it now, though, or to say it again, whenever you raise a negative number to an odd power, the result is going to be negative. So if by error you say -1 cubed is 1, just remember that this is a odd power, so it's going to be -1. So we're going to -1 times 5 is -5, plus this 4 is going to be -1. All right, so let's go from here now with Uniki. So when you look at this question, you know what? It's not. Oh no, careful now, you know. This is happening too frequently for you now. You need to check it out. All right. Copy, then paste, then again arrow it up. And when I do this, Nikaboo, you must see it now. Watch this, Nika. I just put in this little piece here, so all I'm doing is putting this 15x squared over 1. Then I say you cross multiply. Du times 1 is du over, and then 15 x squared times dx is 15x squared dx. Need another line, you know. I need another line. So I'm going to get du equals right? So du times 1 equal is du, and 15x squared times dx is going to be 15x squared dx. See here? 15x squared dx. And then because I want dx to be the subject, I'm going to divide both sides by 15x squared. So the 15x squared will cancel out over here and just leave the dx, and this du have to have a 15x squared underneath it. Tell me, say, see it now.
Oh, so basically, sir, because the equal the the du over the dy equal that, so you just cross multiply and then get cross multiply and then put that as the main one, and then so you move on.
Yes,
Sir, I
ma'am.
didn't know how you get the negative, the one to divide by. I thought it was something special you did, so that's why.
Mm-mm. Any whole number can be written as a rational number. So like the 15x squared is a standalone, but I can convert it into a fraction by dividing by 1. Any something they can convert to a fraction by dividing by 1. Dividing by 1, don't change it. Multiply by 1, not change it. Adding a 0, not change it. Dividing by 0 can't work. Mm-hmm. So now we have all of that. We now need to substitute it into the function x squared. My u now is I want to recall this so that I don't have to be scrolling up and down. All right. So the recall, this is my function. I am substituting my upper limit now for my 4. My lower limit, the lower limit remains -1. Then, sir, every time I do it, one of them going to remain because the second question no, and one of them remain. With the first one, the upper one remain, and in the second one, the lower one remain. Sir, then we alternate like that? No. Then, sir, two of them can change one time? Yeah. Then, sir, when you do them, the two of them can remain the same? Yeah. It depends on the function. All right? So don't just think that is one going to change. In some cases, both of them will change. All right, let's go. Let's go, let's go, let's go. So I'm making a substitution for 5x cubed plus 4x because the substitution is, see, let me make the substitution again to copy. U is 5x cubed plus 4. So this is going to be u to the third power. See it right here, so? And then my dx now is going to be du over 15x squared. Sir, then we never had to make this thing here this subject of the formula because we have a squared? No, because look at what happens. You see, in this case, the x squared here cancels with the x squared that is left in the question. Everybody see that?
Yes, sir.
Mm-hmm. In the first instance, we had nothing to cancel it out. We had absolutely nothing to cancel out. So when we recognized that there was nothing else to cancel out, we had to go back to our substitution to make x the subject of the formula in the first example. But in this case here now, we have our 15x squared under here, so it cancels out with this x squared right up here. So therefore, all you're going to be left with is the upper limit, lower limit, u cubed times du over 15. Cut, bam, paste, undo that, bam, paste, enter, cut, no, what do I need to do? Copy, I need another line here to now show you that I've cancelled out my x squares and copy. Let me just save an extra line and then paste. No, I don't want to take look. I'm gonna paste it here. Oh, there. All right, watch me again now. I did this based on a question that was asked by Sash earlier. And I know there are other students who benefited from the explanation I gave. I mean, I prepare these notes for you. Based on the questions that I asked, I can go and improve on the presentation of the notes like I did the last time with the integration of the exponential function. Look at what is happening here. What I'm saying to you is my x squares are able to cancel out, so this is what I'm left with. From here, this is what I'm left with. But I can rewrite this as u cubed over 15 du. Because remember, when we're doing the question, what it is that we're integrating the function with respect to stands alone. Stands alone. See here, so du stands alone. But watch this magic, Sash. There is again an imaginary one right up here, so I'm able to factor out 1/15. Because this 15 is in the denominator, so I can factor out 1/15, and then I'm going to be left with y cubed, u cubed. Then I'm going to be left with u cubed. So I'm factoring out my constant, then I'm going to be left with u cubed, and this u cubed is going to give me, when I integrate u to the 4th over 4 with my upper and my lower limits. And look what happens. I'm going to have 4 to the 4th over 4 minus negative 1 to the 4th over 4. Now, 4 to the 4th is the same thing as 256, 256. And that is over 4. And when I raise a negative number to an even power, it becomes positive. So that is just simply minus a quarter. So all of this negative 1 to the 4th is going to become 1. So I'm going to have minus 1/4, which is this. Watch this magic. When the denominators are the same, I can just do the operations of the numerator and by the denominator. 256 minus 1 is 255. See here, 255. And I put back the 4. But it so happens that this 15, this question works out very nicely. This 15 is able to cancel into 255 to 17 times. So I'm only now going to be left with 17/4. And that's my answer, 17/4. Now, some students may say, sir, When I cancel this out, I'm going to get 64. Well, guess what? You don't even have to look at this. This was just an alternative way of doing the question, but I ended up getting the same 255 over 60. 15 times 4 is 60, and I'm going to end up getting the 17/4. All right? Do me a favor. I want you to look at the question from here for yourselves. Write it out, look at it, and then we're going to do our final question on it, and then we'll move on. Not spending any more time on this substitution method. You just need to look at the steps. And once it is that you get the steps, you're good to go. I promise you. I promise you. Kez, you have a question?
Yes, sir.
Um,
Up the top there, you said that where the 4 is, it can be changed. When do you know when it can be changed?
Say it one more time, CD.
After the recall, when you're using that sign, you have the 4 at the top. You said that it can be changed. Both of them can be changed. When do you know, or when is it that they change?
The 4-year change?
Yeah.
Oh, you just come to class?
Yes, sir.
Oh, you said good evening?
Yes, I did.
Okay. Watch your honey. This is the original question up here. And it asks us to integrate using the substitution method. So I have to substitute this x, rubbishness. This 0 is actually x equals 0. This -1 is actually x equals -1. But if we are making a substitution for u, we can't substitute negative an x value here. Neither can I substitute an x value right here. So I have to substitute to make u the subject of the formula. I have to substitute for u. All right. So what is going to happen is anywhere in the function I see x, I'm going to put 0. Watch me. 0 cubed is 0, and 0 times 5 is 0, and 0 plus 4 is 4. Magic. I succumb this turn 4, you know. All right. Watch the next one. -1. -1 cube and -1. -1 times 7, -5. -5 plus 4, +1. -1. Magic. So we have to change it because the question now is going to be in u. So I don't want anything in x. So look at what I have to change. I have to change this. I have to change this. I have to change a whole function. That's 3 things. And I have to change this, the 4th thing. Because I have to change it out. You see, like Christmas will come. And you may put up the same curtain, you know, because nothing wrong with the first curtain, you know. But make sure you're going to take it off and wash them. Make sure you're going to take them off and wash them. And guess what? And Christmas will come. Many of you will want to change up your room. Put the head of the bed somewhere else, whatever the situation is. Yeah. I may say, no, I'm going to buy one mat. Yeah. It's the same thing with the stuff. Because the season has changed. So it's not Christmas you're celebrating. The season has changed for this one. It's no longer in X. It is in you. Got me?
Cool.
Easy.
I don't know if you can scroll down, sir. Finish, sir.
Nice. So on the field, because now we're going to get one last one, one digga one left. To do this one on your own. One digga piece left. And I'm excited to start the other section.
Sir, remind me when the bases are different, what you do with that?
When the bases are
I'm feel like trouble there.
Yes, sir.
Is that a trick question?
Me, sir? The question I
Yeah.
asked?
Yeah.
No?
When the bases are different,
Yes, sir.
the powers will have to be the same for you to use it. Is the basis you want to start the denominator, Sash?
Denominator, yes.
I kind of figured that's what you meant. Yeah. If I multiply the two of them together, and then work out the LCM.
Okay.
Yeah, man. And incidentally, there's no trouble to where I'm going to go next. Familiar grounds. All right. So, where am I? Is there anyone in the class that is having a challenge with this? Would you like me to explain something more? Okay. Go through with that one for me, please, guys. I want you to start it, go as far as it can. This is the last topic, and then we're moving on. I have to move on so that I can get to my final topic by next week this time. How many of you have gone through the 45 minutes video I sent you in WhatsApp?
Halfway, sir.
Okay, cool, thanks. Anybody else? Okay, I guess nobody wanted it. All right, no problem. Okay, Sean. All right, start for me, please.
No, sir. Where did just exit today?
Never mind.
I'm confused, you know. Something about me, sir.
What is moving you? All right, let us take it in stages. Have you differentiated the function?
Yes, sir.
Mm-hmm. What is that?
6x.
Good. So what is du? Oh, well, you've seen it. So dx is going to be equals to du over 6x. Agree with that?
Yes, sir.
What's the upper and lower limits?
So I got 70 and 7.
But you can't get them big number there.
Sir, that
Anybody,
we get
anybody else
That
get-
we get to.
Sir, I got that as well.
Okay,
Same
all right.
here.
Great. So I'm happy that you got those big numbers because those big numbers are probably possible.
so my part now, sir, I'm confused about because I see where 6x can cancel the 6x.
Very good.
And it leave with the u cube times du.
Very good. So hold on then now. So hold on then now. So you have successfully calculated dx. You have successfully calculated the upper and the lower limits, and you know what the substituted value is going to be. So u is equals to what? 3x squared minus 5. And then you recognize when you put them in together, you recognize the 6x in the denominator will cancel with the 6x over there, so don't.
Yes, sir.
Yes, sir.
Yeah, and then you're gonna have what? You're gonna have u to the third to integrate.
Yes, sir.
Yeah.
And you get what?
You're gonna
U to the fourth.
The 4/4.
U to the 4. Yes, man. So what
Yeah.
confused it, right? Sashi, I sit on in front of one fan, you know.
Yeah, oh, it's on making noise.
No, it'll blow the information.
Sorry, I wasn't really looking on the example. I was kind
Fair
of
enough.
figuring it out.
Fair enough.
So that's why I'm gonna say look confusing.
Fair enough. All right, no problem. All right, continue, guys. I don't want to project the answer because I want to see how far you can get with it.
Yeah, no,
Um,
no, don't
Sir,
project.
sir, me finish, you know.
You finish? All right. Give me 2 more minutes, Charles. And then, Yanni, I hate when you go to work and somebody upset you at work and you don't talk to me in class. I don't like it. Yanni, unmute for me, please.
Yes, sir.
What seems to be a problem to me?
I don't have a problem, sir.
We can't hear you, honey bunches. Open.
I don't have a problem.
No, I know when you talk to me. Me kind of feel lonely.
Sir,
All right? So, when you talk to me. Avi,
class you absorb. Where you did
you
do this
absorb,
class along with this. So
you
um,
understanding?
yes, so far.
Okay.
So far.
All right, good, good. Avi, come talk to me tonight.
Yes,
What
sir.
you think?
Right, sir.
All right, good. All right?
Everyone, this mean
He said, Avi, Mr. So Avi came on, she said, watch it. Avi. Andrew BC.
I'm good now, sir. I'm good.
All right, very nice. German S. Okay, so if no one to talk, so you can stay muted. Kelly, you all right, no, Kels? She not talking to me
I
either.
don't know what one. I don't know
Not
them big
really, but we're
numbers.
there.
Okay. Nesta, how you feeling now? Nesta Boo? All right, I'm gonna leave you. Lexon, how you say?
I mean, I go and go through, sir.
Nice, nice. Love that, love that, love that. Krishna, how you say?
Yes, sir. It's going good so far, but I only do the part with my screenshot in terms of the
Okay, all right.
example, from the example.
Yeah, exactly, no problem. That's fine. That's no problem. Fair enough. Fair enough. I've soon projected it. Just checking on the others. Nikki, how you say? OSM, Nikki, Anika. Wanna talk to me, man? Call the name, no man.
Sir, we know who you call.
I mean, I know your name, sir.
Sir, me one left for me, but them ears Onika, so I catch on.
How you stay? All right?
Oh,
Yes, sir.
All right, cool. Sash, all right. Shani, all right?
Yes, sir.
Good, good. Miss Lee, you all right? All right. Sean, how you stay?
Sir, can I look after the upper limit and the lower limit?
And that's perfectly fine. All right. So let me help you with this stuff now. So remember I said to you, so recall, you have the original question now. So, the good thing about it is that you already pick up some marks in calculating the upper limit, the lower limit, and dx by the value for dx. The value for dx. And then when you substitute, the upper limit is 70, lower limit is 7, and du by dx is du over 6 is equal to dx. I'm substituting now. So this 6x is this 6x. And all of this is u, that is raised to the third power, see it right here, so. And my dx is now going to be du over 6x. So, and of course, my upper limit, the 5 now turns to 70 and the 2 now turns to 7. Then, sir, as a big number can go to? Absolutely.
Sir, the number different, me,
when they say that, Sasha, I remember I was teaching a course. It could be a calculus course too, either business calculus, pre-calculus, or calculus 1 or 2. And I gave the student, I was teaching additional math, but I was teaching a calculus component in it. And I gave the student some question, and the student did the question, and I said, what is the answer? I'm sitting in front of the class. What is the answer? And everybody's looking at me. Nobody now answer me. I said, guess what? Me now do not need them. So Uno can watch me, and me can watch Uno. And one student carry something and come and say, sir, I dismissed it, but sir, nobody load it up in a sir because it's wrong. I said, what is wrong about it? And then after that, no, when the students heard me say, what is wrong about it? No, everybody in the class shouting the answer. I said, correct. Them never know so that them number there could have been an answer. What kind of number? 6,100,899.79 for argument's sake. Because this just way too big.
Yeah.
Then sir, me get sure, but we didn't think no, it wasn't this question, But I'm just saying for argument's sake, when you get these big, a lot of students say, if something wrong, man, we're supposed to get like 36 and 25. I say no, as long as you have followed the steps, whatever comes out as your answer, comes out as your answer. All right, let's go. So don't be alarmed about the big number 70. When you get the upper limit to be 70, and you recognize that you have 70 raised to the fourth power, 70 raised to the fourth power alone is enough money. Blow, how do I do well with that right now? 70 to the fourth power is 24,010,000. I could have done 24 million Jamaican things with that right about now as money. I'm going to spend all on the school fee for the year and the next year. And then take the rest and just say, go on a little vacation, Mr. Shan. Trust me. But fret not. Don't be worried about the big numbers. The mere fact that you get the 70 up here, so you know so you can have a big number to work with. Had it been 7, you'd only have 2,401. But you have 70, it'll go be 24,010,000. All right, so you have u to the third, You integrate u to the 4th over 4. You substitute your upper limit, your lower limit, 70 and 4. And as I just said a while ago, this is what you'll get. You're subtracting your numerator, so this is what you're left with. Divided by 4, your answer is going to be 6,001,899 and 75 units squared. Now, how
Sir,
can you
question
go ahead?
before you move on. We could I leave it as the fraction or have to divide?
You could leave it as a fraction. I won't kill you. If the question says as a whole number, you'd have to go leave it as 6,001,900. If it's as a whole number, you can't leave it as a fraction. But if they want to tell you, say, leave it as that, if you left it at 2007599 over 4, may I give you the full mark. But if the question say, leave it in decimal form or leave it in that form or that, yeah, me. I will take off a mark or two. But once I don't give you any indication as to how to leave your answer, and how you write it, you might get the full marks from it. Real tough.
Sir, na front Mr. again, sir.
No, man, you're good. All right. I'm going to do a little housekeeping before I move into the second to last topic because I'm finished with this. I'm not going any further. I'm finished with this. But before I move into the second to last topic, based on my recollection, I mean, I'm going to use a day or two over the Christmas break to just brainstorm because I know that I have one or two little graphs to look at with you. I remember. And of course, L'Hopital's rule and first order differential equations. So all being welcome January, we can just put the icing on the cake and then we know that we'll finish the syllabus in its entirety. And then we can just ready for the people then exam so we can just get with A's and then move on to only calculus 2. But I sensed something, and I sensed it from about last week this time. Today's Thursday, I sensed it about from last week this time. And I'm gonna say, if it doesn't apply to you, I apologize. But if it does, make we have a conversation. I am sensing with the class fatigue. Is there any truth to that?
Correct.
Yes, sir.
100 trillion time.
Yeah. I sensed it from last week. And on Tuesday, I won't tell you where they're coming. More and more people are coming into class later and later. It may very well mean because of the Christmas season, you have to stay at work a little later, or maybe because of the traffic to get home, or whatever variable, preventing you from coming out early. I never normally had a problem with the 7 o'clock class because you'd have already been home and somewhat settled, and then you join pretty early. But up to 7 o'clock, I was the only one in class. Then up to 7:15, when I said good evening, there were only 10 of you in class. And, I didn't comment on it because I'm saying to myself, I am sensing fatigue, and the truth is, I appreciate every one of you. You don't all turn up to class at the same time. I may have had all students in the class. Well, I've had all of you in the class at some point in time. I know for the mid-semester I did. I know for the mid-semester I did, but let me just encourage you. The truth of the matter is I'm right where you are. On Monday of this week, I sat in this very chair trying to prepare for the institutional accreditation, vetting session, ratification, plus battling my 3 courses that I'm teaching and doing my notes preparation. My notes preparation takes a lot time. I have to reflect on the topic that I'm teaching to see how best I can present them, what stance I'm going to take in presenting them. So it takes a lot in terms of preparation. And the truth is, I I was reading a document to say, for another course, to say, okay, fine, another course that I'm teaching for the first time, and I'm saying, you know what, okay, let me just go and prepare this. And for the last 2 weeks, I have some information on my tablet to read, and every time I read it, I just drop asleep because yes, we know every night I'm teaching, um, and 3 nights out of the week, I go 9 o'clock 2 nights, and I go 10 o'clock one of the nights. And then on a Friday when I go up to 9 o'clock, the class is really 8:30, but sometimes I'm there for 9. Uh, I'm back up early at 8 o'clock on a Saturday morning. So here what is going to happen. I want you guys to make sure that you're on your vitamins because you don't when you're fatigued, it means that you're more now susceptible to anything. So if little breeze blow, like by the time I get chilly now, we're not gonna catch one cold. What if somebody sneeze from uno? What if breeze little blow and little dust pick up and it catching on the nostrils? Um, you're going to be more susceptible, to catch anything. So what is important, please, don't tell me say you can't afford it because it's your health. Get some vitamins and start to boost your immune system. Get some, what do you call it? Vitamin C, get some B complex iron, get some zinc in the system, just get something. Get something in your system, and then couple with that. In the last couple of classes, people are sending me messages that, sir, I am not well. So I was going to answer to just take care of your body here, please. I know Christmas have come and you want to put in a little
Sir,
extra hours. Yes, please.
you want to get the joke?
Mm-mm.
I went to the doctor this week, and the doctor said, find one deep hole and hide for 2 or 3 days. Sir, my pressure was 200 and odd over 100 and odd.
Are you serious?
Yes, that is the amount of stress I'm under. So when you see me now respond to you, sir, you understand now.
No, but Kelvito, no, that a cemetery talk, No, man. Mm-mm. Kels, let me tell you something. As I said to another student in a private conversation, when you worry about the problems, it not change it. Leave it alone. Leave it alone. You worry about the problems you have, leave it alone. It not change it. Come on, Kels, you have to be careful, honey bunches. No, you can't do that. And it goes for anybody else. Leave it alone, man. I know some people say, boy, got well. For example, um, courts have come back for them something. Them have to come back for me, them come for you. But sir, me go shame when people make them talk. Yes, Jermaine. Um I'm going to say something and then we'll move into the other topic. So I have an apple tree and I'm now doing some work in front of the apple tree. So the workmen are at home doing some work in front of the apple tree. So I went out there with the workmen, not that I'm supervising, but I'm just watching what they are doing. And I'm hearing this buzzing sound. And when I take stop and look up, the apple tree, I recognize that. Well, I knew it's blossoming because you can see the evidence on the ground, right? But I didn't recognize that there were so many blossoms on the tree, or young apples, so to speak. But inside of those were the worker bees. And every one of the something then, the bees inside here taking out pollens. And I said, wow. And I said to one of the workmen, God good enough. Because in him tell me, say, why worry and you can't add a foot to your height? The man say, the big man say, him take care of the birds of the air and the lilies of the field. How much more will he take care of us, me and you? And I stood up and I reflected for a couple minutes and I said, why Jesus, you good enough? Because see the bee, them no one for go make honey. And you provide my apple tree for them come take the pollen and the sap and everything out of it. I said, wow, you good. And then when I look, a lot of birds come by the house. And for fun, I'll just go and just buy bird feed and just put them in different containers. And so I attract a lot of birds, right? Trying to catch one or two of them, but it not work, right? And I'm saying, but just look at that. The lilies of the field, the birds of the air, the fish in the ocean, him take care of them. Him going to take care of me too. And him going to take care of you too. Hear the plan. Kills and the rest of you know, allow the problem alone here. On allow them alone. On can't change nothing. If it's a sweet for God, a sweet for God. So I kind of sense that there was something because there's a tenseness in for the class. You know, it's not what it used to be at the start. You know, I kind of feel it, and it was part of the problem why I took the class outside on Tuesday. Because part of the reason I took the class outside on Tuesday when I was lounging to have a tea, because I recognize that I also need to take
Remember never do outside.
No. I had to go outside.
Yeah, you sir, not the class.
No, well, I had to be because I internalize somewhat when I'm trying to teach and I don't know if students are understanding and students are not responding to me. It takes a toll on me because I'm saying, am I not speaking clear enough? What is it that am I not doing? And even after class, I am reflecting on it, not worrying, but just reflecting on it. And I say, but I did what I was supposed to do. But if they don't want to answer me, we can't do nothing more about it. I am going to move on, right? So my post class is always because I'm very critical about myself. I think we do justice with this, But no, mom, I cannot do justice with it, right? So it is important for you to give me feedback. It is important for you to come a class even when you have problems. Even when you have problems. Because if I have problems, none of them will know. You know why? It's not for no business. For no business is on a pay on a school fee for Mr. Shan teach you. I don't want to come hear my problems. I come teach you. When I done class, I can say, all right, I need to deal with this, I need to cook food. I'm hungry. But no, guys, relax yourself. Relax yourself, take it easy, get some vitamins, take care of your blood pressures. Just take care of, and as I speak to you, I'm speaking to myself. As I speak to you, I'm speaking to myself. Just go easy, and you'll be fine. Go easy. I know it's rough, and I know some of you may want to work some late hours because you're trying to earn a little bit more, school fee for pay, exam for coming, and then you start. And know it alone here, man. It is better for you to not have a Christmas, but when you're still living, than on a run on yourself into a wreck here. And what is Christmas?
Sir,
The birth of Jesus. Yes, honey.
remember the place that you said you can go when you feel like, sir?
Listen to me, man. Talk truth.
You remember the
Listen.
place, sir?
Me
Set
fi
me
te-
up now.
me say, me fi tell you. No, man. Me tell you, man. Trust me. Right. Talk truth. Right about now. In the night, you're something no crazy.
So you not answer the question,
You know, answer.
No, but me tell you,
You just
talk
go
truth.
around the corner, just send on the link. Yeah, me need one dark hole if you go in now. Send on the link.
No, but seriously though, Kels, can you take some days off from work?
Nah, I get it till the last week of December.
Jesus. Can you stop worrying, Kels?
Hi. No, no, sir.
Yeah, play with me. Yeah,
No, I
play with
play with
me.
you, sir. Sometimes, trust me. When me think some me have 200,000 I have to pay Excelsior. I owe so much money. You have to deal with so much things.
Yeah. But you know, guess what? This too shall pass.
It need to hurry up and pass.
And guess what? You worrying about it won't cause it to go quicker. That's the point I'm making. That's the point Germany is making. This too shall pass. All right, let's go. Now that we are good again, let's go. So again, just to let you know, put a little twist on it. I am eternally grateful to the class. You have been, I mean, it's a model group. It's a model group. Some of you have interacted with before, and I know what it is that you bring to your education, and some of you are interacting with for the first time, and I am pleased. I mean, for the most part, there are some of you who have to squeeze in the talk, but for the most part, I'm pretty pleased. All right, I am on to my penultimate topic, and it is on applications of differentiation, and then I'll go further now to application of integration. But it's because I was doing integration up to now, I am taking a little break from the integration to go back to some differentiation. And then when I finish the differentiation, then I'll go back to integration. I said something to Sash on Tuesday. Sash, if we get to do the quotient rule, so I'm excited that I get the chance now to just explain some stuff. And then I'll go back to the integration. And then when I'm finished with this topic, we'll finish with the calculus aspect of it, differentiation, integration. And then I'll move into the final piece, which is FODE, first order differential equations. I may, if I find the time, I may do a voiceover like I did for this week and send off to you. I may do a voiceover on the first order differential equations, especially if I don't get a chance to do it for Christmas. I do the voiceover so at least you can have those for the Christmas break. So it's easier when we come back in January that we just breeze through. So let me bigify this and let us talk about our applications. Now, we're looking at some stationary points. So we're looking at stationary points, single variable functions. Single variable function. We will be doing questions on multivariable function, but this one here is single variable function. And the multivariable function will be done in calculus 2. The single variable functions are done here. So what I want you to know, because I want to go through all of this piece here and then do a full question and then we can just call it a day. Let me get my pointer since I'm going to be doing a lot of talking here. Where are you? There you go. So note, f of x is equals to y. F of x is equals to y. So I can give you a function in f of x, but I can also give you a function in y. I could give you a function in g of x, and I could give you a function in y. I can give you a function in h of x, and I can give you a function in y. So, you know, you always hear students say, but f of x is equals to y, sir. Yeah, right? Now, if I give you a function in f of x, it means that f dash of x is going to be the first derivative. It means that f dash of x is going to be the first derivative. And if you get a function in y, it means that f dy by dx is going to be the first derivative. First derivative or first differentiation means the same thing. And f double dash of x is going to be the second derivative. You know this, you know. This is revision, you know, because we've done differentiation long time. And d squared y by dx cube is going to be the second derivative. All right? Watch me now. So we need to determine stationary points. So to determine a stationary points, I'm going to go through these rules You may not get all the rules at once, but when we start doing the questions, you will see how these rules apply. So to determine the stationary point, we need to differentiate the function, say for example, f of x, or say for example, y. So we need to differentiate the function, Now, we are going to be setting the differential equals to 0. So if the function is f of x, we're going to find f dash of x. Now, when we find f dash of x, we're going to set it equals to 0 and then solve for the unknown, right? And this will give us the critical values. Now, solving for the unknown, more than likely you have to go and factorize. And oh, I know you love factorization. So you have to go and factorize in order to solve for the unknown. And then this is going to give us our critical values. Right? Now, then you're going to substitute these critical value or values into the original function f of x up here, so. And the result together yields your stationary point, your critical points, your turning points. All of them mean the same thing. And those will be written in the form x, y, which is a coordinate. Now, let me just explain something here. So one youth in another class, you drive a white car. I won't tell you the model, the make and model of the car, but drive a white car with some purple something tie up at the front of it. I want to get another car, and just change it out and just put the sky blue in there, because the person is just misguided. But anyhow, that person swears say them is the best driver, but clearly them never see me drive yet, and them can't test me, Test who? Left them a road, man. So guess what happened now? You see that person? Them feel say, if them a leave out of exit or go up on the road, and the member say them left them laptop under the desk and want turn around for come and exit, them can just spin the car come around without stopping. Can't happen. Not even the best, not even Paul Walker, may his soul rest in peace, in Fast and the Furious.
Oh God, the
Couldn't have
last
that
time
help.
the glimpse is showing us, sir.
Trust me. Trust me. Trust me. Couldn't do that. So you have to come to a halt, even a nanosecond. Even a nanosecond. No, it's when it come to the halt, and that we call turning point. It means you're going in one direction, and then it turn and go in one opposite direction. And that's what they call a critical point. And that's what they call stationary point. Stationary means that you stop, right? The ERY is pen and pencil. The ARY is something else. All right. So this means that you stop at some point in time, whether a nanosecond, which is a piece of a second, just a look to the points of a second, but the car is going to come to a halt at some point in time in order for it to change in direction. Because if it don't come to a halt on its own or by you, it will come to a halt on its own because it will turn over. Because you're going with a velocity in one direction to change in the opposite direction can happen. Think of a fan. Think of a fan. Most fans you can pull a string to reverse the spin. Are they going to go clockwise or anti-clockwise with the spin? Now, if I try to reverse my fan has to come to a stop before it can go into the opposite direction. Real talk. We don't believe me, try it. All right? That's what this means. Turning point and something here, right? So again, to calculate the stationary point, and all of these things are the same thing. So sometimes you hear they say stationary point, or they may say critical point, or they may say turning point. For calculus too, they have a different terminology for them, but are the same something. The same something, all right? Watch me now. So to determine the stationary point, you're going to differentiate the function, set the function equals to 0. You're going to be solving for the unknown or unknowns. Then when you get those unknown or unknowns, they will be known as a critical value or critical values. You're going to substitute those critical value or values into the original function in order to get your critical points, your turning points, or your stationary points. So now we need to go ahead and classify the nature of the critical points. We need to classify the nature of the critical point. Oh, these things are very nice. They are curvulous and they are very nice. So we need to determine the nature of these critical points. Are they a relative maximum, a relative minimum, or a saddle point? So we need to determine whether or not we have a max or a min or a saddle point, a maximum point, a minimum point, or we have a saddle point. All right. So to classify the nature of the stationary point, we are going to use the first, we use the first differential, f dash of x, and we are going to differentiate it a second time in order to find f double dash of x. So the first differential, f of x, we're going to differentiate it a second time in order to obtain the second derivative. Remember, start off up here, so? Because you get the original function here, so? You have to first differentiate it here, so? In order to find the stationary point. Now, when you're determining the nature of the stationary point, you have to go right up here, so. Right? That's why I put all of this here, so because all of this we have to do once it is that you're talking about the applications of differentiation and looking at your stationary points. All right? Now, you're going to substitute the critical value or values in the xy form into your f double dash of x, into the second derivative. If the second derivative is positive, meaning that it's greater than 0, then you have a relative minimum. If it's negative, less than 0, you have a relative maximum. And if it equals 0, you have a saddle point. Easy 1, 2, 3. So if it is equal to 0, it's a saddle point. If it is less than 0, it's a relative maximum. If it is greater than 0, it's a relative minimum. But certain things say if it's greater than 0, it's going to be a maximum. No. Maximum turn down, minimum turn up. Right? So when you differentiate the function, the first derivative, to get the second differential, you're going to substitute your critical values, value of values, into the second derivative. If it is positive, you have a relative minimum. If it is negative, you have a relative maximum. And if it is equals to 0, you have a saddle point. And of course, you don't have to worry about this because you know that I'm going to be sending these notes to you. All right. And then method 2 is when you talk about the graphical method that I'm going to show you in example 2 below. All right. Then to determine the intercepts, why did I not do like that? To determine the intercepts, to evaluate the x-intercept, you put y equals 0. That's something that you know from little school. To determine the x-intercept, you put y equals 0. To determine the y-intercept, you put x equals 0. To determine the x-intercept, you put y equals 0. To determine the y-intercept, you put x equals 0. Put it this way. You can't determine the y-intercept and you put a y equals 0. It has to be the opposite one that you're putting in. That's how I remember it from little school. So if I'm finding the x-intercept, I can't put in x equals 0. The other one I have to put in. So look here. X-intercept, you put in y equals 0. Y-intercept, you put in x equals 0. All right? So that's how we determine our intercept. So that's 3. Number 4. To determine the point of inflection. I notice I said inflection, not infection, but inflection. We're going to be using the second derivative and set it equal to 0. Remember, we would have found the second derivative from before. So we are going to set the second derivative equal to 0 and solve for the value or values of x. We're going to solve for the value or values of x. Then we're going to substitute those value or values into the original function, which is 1 above, and then write on the coordinates of the point of inflection. All right? Please note that the point of inflection occurs between two critical points at the midpoint. So the point of inflection occurs between two critical points, and it's going to be the midpoint, the halfway point between those critical points. All right? Note also, if the question gives you only one critical point, it means that it has no point of inflection, because a point of inflection occurs between two critical points. Very important, and important enough that when I was doing calculus, I had to come back and make this notation. This occurs only for continuous functions. It occurs only for continuous functions. Only for continuous functions it works. All right? So that's the point of inflection. And then we're going to sketch the graph. Then we'll sketch graph. I want you to look at that one for me. The question says, given that the function y is equal to x squared minus 6x plus 1, we need to evaluate the critical points. And I want you to take a minute to read through the question. And then see how it is that I differentiate it and set it equal to 0 right here. Give me a minute. I want you to do that for me in exactly 2 minutes. I want you to do that for me.
And what you want me to do?
I want you to look back at what it is that I have there. Just look through the first part of the question that I have.
Okay.
Always stay. You talk to me now. Okay, I think I'm muted. Hello, somebody?
So I'm just a look through it, you know, sir.
But answer me when you answer question. You're not going to talk to me, you know that too. All right, so this is what is happening. So we're given a function y equals x squared minus 6x plus 1. And the first rule says that we have to differentiate the function and set it equal to 0. So when I find dy by dx, I'm going to get 2x minus 6. The differential of constant is equal to 0. And then now I'm going to put the 2x minus 6 equals to 0. Because having found the differentiation, I have to set the differentiation equals to 0. I have to set the differentiation equals to 0. Now, when I set 2x minus 6 equals 0, I'm going to end up with 2x equals 6 and then divide both sides by 2, x equals 3. So this is how I got my x to be equal to 3 right here. Do you recognize that I have only one critical value here? So that x equals 3 is my critical value. Now, I have this over here. In particular, for those students who would have done Foundation Concept 3 with me, or not necessarily with me, but with anybody else, would have done the course FCM 3. Now, I know whenever I'm teaching like a group of computing students who I know will end up, and not even computing students only, but with students who will be moving on to any calculus, business calculus or calculus 1, and make reference that when I'm finding the vertex form, that it's going to come back to haunt you. So I often say to students, pay attention here, because this piece is going to come back to haunt you. Because when it is that we use h is equals to b over 2a and k is equals to c minus b squared over 4a, this is completing the squares. And when I complete the squares, I'm going to get my vertex to be 3, -8. Now, if you are smart enough, you will see that this x equals 3. And in my xy form, you know that x is in this position, so you can assume that y is going to be equal to -8. So look to see if I can now use another method to get my y to be equal to -8. Point is, and you don't have to know this method. I'm just making a correlation here. Point is, when you're doing FCM 3, you're actually using an application of differentiation that you didn't even know that you were using. And this is coming from first principles, beginner step. All right. So now that you know, we can see the correlation from what it is that you're doing. So you can make a connection now between and among courses. Right. So one is building up to the other. Okay. So remember what we did. We are given the function. We are differentiating the function. We are setting the function equal to 0. We are setting the function equal to 0. Now, when we set the function equal to 0, we're going to have 2x minus 6 equals 0. Then we're solving for the value of x. We're solving for the value of x. I did say to you, more often than not, you're going to get a question that is going to ask you to factorize. More often than not, you're going to get a question to factorize. All right? But this one is a simple one. I choose to start off with a simple one so that I can, move on into the other ones. So let's go. Let's go. Is there a question?
No, sir, sorry about that.
Okay, cool, no problem. So now, my critical value is x equals 3. So I did say to you now that I must substitute now my critical value or values into the original function. Into the original function. All right? Into the original function. So remember the original function is, let me just copy this, in case I don't have it there. X squared minus 6 plus 1. All right? So I'm substituting in the original function there. Oh, crap. Forgive me. All right, let's go. So anywhere into the original function, I see x, I'm going to substitute 3, my critical value. 3 squares, see it right here, so. Minus 6 times 3, see it right here, so. Plus 1, see it right here, so. 3 squares is 9, negative 6 times 3 is negative 18, plus 1. 9 minus 18 is negative 9, negative 9 plus 1 is plus negative 8. So I get my negative 8 here, so my critical point is going to be 3, negative 8. But we figured that out from those who would have done foundation concepts 3, that my vertex form a, open bracket x plus h all squared plus k, but that's giving me 3, negative 8. Long time. 3,
So you don't have to
negative.
you don't have to use that part, that one.
No. I'm only making a correlation. For those of you who may have been introduced to foundation concepts 3, I'm only trying to make a correlation. If you never did foundation concepts 3, don't even worry about what is on the right hand side. So this piece over there is only for those who did foundation concept 3. All right? The rest of you, and I mean, it's not for the ones who did foundation concept 3 to do the question here now. I'm only refreshing their memory. I'm recalling what it is that they would have done to now say to them that, a big mathematics you do when you have the foundation concept 3, something. Big things you do. All right? So y is equal to x squared minus 6x plus 1. You differentiate it, you set it equal to 0. And when you do that, you're going to get, what do you call it? Your x equals 3. You're going to put your x equals 3 into the original function. Then you're going to spit out negative 8. That is going to be your critical point. So the question says, evaluate the critical point or points. That it says to evaluate the coordinate of the y-intercept. If it is y-intercept, which one to put equal 0?
Yeah, Sean.
Who both for you, Sean?
Sir?
Who
Oh,
both for you?
sorry, I was listening to somebody else. Sorry about that.
You speaking to somebody in the class, boy? Let's go. Let's go. That was asked. Yeah, I did ask a question, but let me ask the question again.
Hold on. So it's just critical point alone with this, sir?
Just a while ago, yeah. Yeah. So here the other question now. It says to find the coordinate of the y-intercept. How do I find the y-intercept? What do I plug in order to find the y-intercept? Let me see how many of you are remembering.
X.
X what?
Say
equals 0.
X equals 0, sir.
Very
X
good.
equals 0,
So,
y equals
right.
0.
So it has to be the opposite one. So I can't say I'm finding the y-intercept and putting y equals 0. No, it has to be x equals 0. It has to be x equals 0. Has to be x equals 0. So this is what I'm doing. So the coordinates of the y-intercept, put x equals 0. Always remember that. If you're asked to find the x-intercept, y is going to be equal to 0. If the answer to find the y-intercept, x is going to be equal to 0. When you're finding the intercept, it's going to be the opposite one. That will be equal to 0. The opposite one. That will be equal to 0 every single time. The opposite one. that is equal to 0. So all I'm doing, anywhere in the function I see x, I put 0. 0 squared minus 6 times 0 plus 1. And my y is going to be equal to 1. So watch this now. Remember the question said a coordinate. Whenever you talk about coordinate, you talk about x and y value. It speaks about your x and y value. So you see up here, so x equals 0 because that's what you know. And you just work out the other piece, y equal 1. So the coordinate of the y-intercept is going to be 0, 1. And a 1 mark, let me give you that, because that's not hard. 1 digga mark, let me give you that. That's not hard.
Sorry, quick question before you continue. This would be a section B question.
It really doesn't matter because the whole paper is compulsory.
Oh, okay.
Is it the point I'm making, Sean?
Yes, sir.
But to answer your question, yes, it is. But also, though, they could give you a question, a very simple question like this for the multiple choice. They could give you a simple one like this for the multiple choice. So either way. All right, so let me go again. So to find the stationary point, I'm going to set y dy by dx is equal to 0. So I've given the function y. I'm going to be differentiating the function, set the function equals to 0, solve for the value or values of x. When I get that value or those values of x, I'm going to substitute into the original function to get the y value and put both of them together to get the critical point. Remember, a point has both an x value and a y value. All right, that's why I get my critical point. Now, to determine the nature of the critical point, I will have to differentiate the function once more. That means I'm finding f double dash of x or d squared y by dx squared. When I would have found those, I'm going to substitute my critical values, points, into the function. And I'll come back to that. I said value a while ago, and there's a reason why I said it. And then there's also a reason why I come back and say critical points. I'm going to substitute my critical points into the function. And when I do, if the value comes out to be positive, I have a relative minimum. If the value comes out to be negative, I have a relative maximum. If the value comes out to be equal to 0, I now have me a saddle point. To determine the x coordinate intercept or the y-intercept, I put the opposite one equals 0. So this question asks me to find the coordinates of the y-intercept. I'm going to put it x equals 0. Now the other question says determine if the critical point is a maximum or minimum. I am now going to be finding the second derivative. So remember, I'm recalling now that dy by dx is equal to 2x minus 6. So where did you get that from? From all the way up here. See here, so? Dy by dx is equal to 2x minus 6. Now remember, when I'm finding the intercept, let me go back to that. The point of inflection, I have to find the second derivative. When I'm finding the point of inflection, I must find the second derivative. Must find the second derivative. So let's go back to the question now. The question says, and also, I can use a second derivative in order to classify the nature of the stationary point. I can use also the second derivative in this method because there are two methods. There's a graphical method that I'm going to show you below, and there is the calculations method. And the calculations method is by using the f double dash of x. To be honest with you, the graphical method is nice, but more students gravitate towards the calculations method. All right. So we are going to classify our stationary points. So this is my dy by dx. I'm going to be finding d squared y by dx squared. It sounds big, but all I'm doing is just differentiating this one more time. That's all I'm doing, just differentiating this one more time. So when I differentiate the function one time, I have dy by dx. When I differentiate the function another time, I'm going to have d squared y by dx squared, which is the second derivative. How you know it's the second derivative, sir? You have the 2 between the d and the y in the numerator, and the 2 after the x in the denominator. Yeah. Then, sir, oh, when you have dy by dx, you don't have the 1 up there. You know that there's an imaginary one? Real talk. So if I'm going to find a third derivative, it will be d cubed y by dx cubed. The fourth derivative, d to the fourth y over dx, dx to the fourth. All right? Okay. So now, what will be the third derivative of this function?
Zero.
Excellent. Just ask the question to see if you're still awake. It will be 0. Very nice. Very nice.
Sir, alpha awake.
Alpha awake, never mind. Alpha love better than none. Just make it 17 more minutes. Or just enough time to go through this question and ease enough little tonight. So now, I would have found my d squared y by dx squared. The question says I'm supposed to substitute my critical point into the function. But this function here has no x value or no y value for me to substitute. So I'm going to use this d squared y value by dx squared. What value is this?
Constant.
It's a positive value, right?
Oh, yeah.
Yeah, it's a positive value. So because it's a positive value, I'm going to use it as it is. So because it's positive, I'm going to have a relative minimum. And ask me if I have a minimum or maximum. It's going to be minimum. Why, sir? Because it's positive. Sir, how you know that? See here? If f double dash of x is greater than 0, if the second derivative is a value that is greater than 0, then you have a relative minimum. If it is less than 0, you have a relative maximum. And if it is equal to 0, you have a saddle point. You have a saddle point. So, looking at this, we recognize that d squared y by dx squared is equal to 2, and it's a positive 2 too. Relative minimum. Straight minimum, sir. So that's why I have minimum right here.
Sir. That means the third derivative would be a saddle point.
The third, and the thing about it though, that we don't use the third derivative in the calculation. I only answered that because I wanted to see if you were awake and if you were thinking that, you know, when you differentiate a constant, you get 0. But the question will never ask you to do the third derivative. To do this piece of question, the application of differentiation is just the first and second derivatives that we use. At no point in time will they ask us about the third derivative. Not at this level. Not at this level. All right. And then now we're going to be sketching the graph. We're going to be sketching the graph. So let me just remind you of some points. We have 3, negative 8. 3, negative 8. Watch me. This is 1. This is 2. This is 3. So this is my x value being 3. And my negative 8. And it's positive, so I go to the right. Had it been negative, I'd have gone to the left. Positive y goes up. Negative y goes down. And you recall that it is 3, negative 8. That means the y is a negative value. If I go here to be 5, watch it. 1, 2, 3, 4, 5. So each spacing inside of this grid line represents 1 unit. That's 5, 6, 7, 8. So it means that this point right here, so right where you see my spotlight, is my turning point. It represents my turning point.
Oh, sir, say critical
Say it
point.
again.
Point.
Say it again.
The critical point is always a turning point.
And always my stationary point.
Okay.
So I use them interchangeably. Critical point, turning point, stationary point, all mean the same thing. Very important for you to remember because there are times we're working past papers, and we may only see the question ask about stationary point. And then bam, we go in the exam and they ask for critical point. And I say, blow, whoa, sir, never teach you this. So yeah, man, critical point is the same thing as turning point, same thing as stationary point. Please don't forget it, you know.
So is the turning, critical, stationary are all the same, right?
All the same, yeah, man. All the same, won't change. All right. Hmm. That's our second example. Not doing a second example yet. Not until next week, because I want to do some exploration with you right here. It says that I'm showing all points. I'm showing all points. And when I say all points that I would have calculated in this question. So the first set of points I calculated was my critical point, 3, -8. Then I have my y-intercept, 0, -1. 0, -1. See it right here, so? 0, -1. It tells me where the graph cuts the y-axis. That's why it's called the y-intercept. That's why x is equal to 0, incidentally. Because when the graph cuts the y-axis, it cuts it where x is equal to 0. X has no other value but 0 when it crosses the y-axis. Similar, y has no other value but 0 when it crosses the x-axis. That's why it's going to be the opposite. All right? Work with me now. So we're going 2 values. And then now we need to determine, so we have those 2 values. And we know that it's a minimum graph. So minimum graphs turn this way, upwards. Minimum graph turns this way, upwards. Are there any questions? Let me just confess something to you here now.
So how much page this reach?
Huh?
How many pages working out reach?
This one? So it can go sometimes 3 pages, but the good thing about it is that there's a question that will come if you get a question on this for like 20 marks and like 25 marks. It's a full question. And incidentally, I think I was saying this to you. The topic here is a must-have. It's one of those staples on a Calculus 1 paper that every Calculus 1 paper you take up, you know, so this is on it. It's a staple.
Oh.
So if you never pay attention before in class, pay attention now. This one is a staple.
The recording, I watch that one here, sir.
It is a must-have. You cannot do a Calculus 1 paper and don't look at the application of either differentiation or integration. It's a must-have.
I recall seeing it in the past papers.
Yeah, man, it did it. And anyway, it's not there. That is a poorly written paper. It did it, man. So let me confess something to you. I don't have me a working graphing software. It's like I have the typing one that when I send it the paperwork, it look like a textbook, something send it, don't it? Talk through.
Repeat that, sir?
I'm just saying when I send you the notes, it look like I want textbook notes. It type nice, don't?
Yeah.
Because I use a software for the typing of these stuff. But for the graphs beating me, and I'm trying to find a software, whether or not open source, but one that I can manipulate in such a way that I can get my graphs in such a way. Because remember, I never did the first part of the graphs with you. And I said to myself, I'm going to wait until I get to this point, and I just do everything in the graphs. So what I want to do in another 5 minutes or so is, and I don't know if you have any space on your phones, but I want you to download for me.
Sir, negative.
We know. So those of you who can download, I'm going to ask you to download, because part of the things to ask about using we call it graphing software. So I'm going to ask you to download Desmos, DESMOS calculator. Desmos graphing calculator, DESMOS. Desmos. Go to your Play Store, go to your App Store, Desmos Calculator.
Repeat that name, sir.
DESMOS. Desmos Calculator. And we're going to have a conversation. Oi!
Wow, sir.
Yes, on.
My phone was gracious in granting me a space.
Oh, glory.
Desmos graphing calculator.
It's same one. You're going to, when you open it up now, what you're going to do is, the interface is pretty easy to use. When I say pretty easy to use, pretty easy. So you're going to open the interface, and what I want you to do, play around with it. I can't teach you how to do that. Play around with it and put in a function y equals x squared. What was the function? Minus 6x plus 1. Put in a function y equals x squared minus 6x plus 1, and then graph it, and then tell me what it looks like. Compare it to the one that is on screen from your cell phone or your tablet or your phone, whatever it is you're using.
Yes, sir.
It look like it, don't?
Yeah.
All right.
Repeat the function, sir.
I think it's x squared minus 6x plus 1, x squared minus 6x plus 1.
Equal. So in this case, sir, being that we're gonna do this question in the exam, we would use this device.
No, no, you will have to go and sketch a graph. You will have to sketch a graph, but guess what? A part of your syllabus says I'm supposed to be introducing to you calculus software. No, this is the first one that I'm introducing to you. It's an open source for you to know what what the graphs look like. Why I introduce you to this software is because when I give you questions to practice, and you get a lot of these questions to practice, because as I said before, it's a staple, and I expect it to come. I'm not going around or something. I'm saying to you, it's going to be there. It's going to be there. So what I'm saying to you is, because I'm going to be giving you so many of these questions, and normally when I give you questions, I give you the solution, so at least you can work towards the solution. I want to be able to give you the graphs. So you now can check your own graphing. And also to know how to use the stuff. Because that same software can be used to matter of fact. That's why I said to you that I remember that I didn't do the graph switch at first. Remember, I don't like piecewise function. Look to the top left-hand corner of Desmos, and you may see 3 lines. I think is it 3 lines at the top? Click on it for me.
Now.
Yeah, go to the menu. Click on it for me. Go to the menu, and scroll down to P and see if it's a piecewise function. Anybody, somebody?
Not seeing it, sir.
There is supposed to be a search button in Desmos. Put in piecewise function in the search button. Anybody, somebody?
I don't know if I download the right one, but I'm not seeing a search.
No, man, you don't know the right one, because the mere fact that you say seeing the graph is the right one. Anyhow, so I will come back to that one. I It's just that my document camera is not picking up with this computer and the other computer is in use. So hopefully next class I can use the other system and demonstrate from my phone or my other device what it is that how it is that I'm using the stuff. What was I going to say to you now, Lord? Right. So you can actually use it to sketch your piecewise functions, because one of the things that they will ask you to do for the exam too is to sketch the graph, the piecewise function. But you know that I didn't do any of the sketches at all for piecewise. So this is a time now that we are going to be looking at all the sketches. All right. So and again, one of the things is for you to see that what it is that I would have done is indeed correct. So the piecewise function, we are going to be looking at our stationary points. We are going to be asked to sketch a graph of the function and indicate on the graph how it is that we're going to sketch a graph. The critical areas that we calculated, every one of them, all of them must be represented on the graph paper. All of them must be represented on the graph paper when it is that you're asked for the sketch. So if you go into the exam and it says sketch, every single term, every single point that you calculate, the critical points, the turning points, the classification of that, every single thing must be represented on the graph paper. A matter of fact, it's not even a graph paper because you're not plotting a graph, it's a sketch. And there's a difference between plot and sketch. There's not graph paper. Sketch is when you use your paper, blank paper, whatever paper on leaf on tree, for just sketch something. Graph paper is when you're actually going to plot, and we're not doing any plotting. All right. So I'm going to end here. And then right there, I will send you the notes momentarily. I'm happy that I was able to introduce the applications to differentiation integration. Truth is, this one, based on your syllabus, this one is a repeat of what it is that we did last time around. Pretty much on your syllabus. I need to follow your syllabus to make sure that I'm covering your syllabus here. You'd see that this one on your syllabus has nothing relating to what it is that I'm doing here, because it was poorly written. But based on what I am seeing in the other areas, and as well as the past paper, it will include what it is that I'm doing here. So the applications of integration and differentiation this is the only application of differentiation that we'll be looking at. And the other one is to find the area under the curve, and then we'll finish with this. So this one I should be able to wrap up by next week for sure. And then we just have one area that is left. All right, guys, as per usual, thanks for coming out. May God be with you. Remember to say drink with Jesus before you go to bed. Eh? Have a good one.
All right,
Thanks,
sir.
sir.
Come on, bless up.
Night.
Yeah, night there, sir.
You know, easy.